So today I'm speaking with Zach Zimmerman of BamCore, a company creating wall systems with bamboo. BamCore also received a 2021 Ivory Prize Award for housing affordability. So welcome, Zach. Zach, let's start off by having you give us more background on BamCore as a company.
BamCore was actually founded in 2008, but it really was not until 2015 when the company started to commercialize itself. There was a lot of stepping stones that happened between 2008 and 2015, but effectively here we like to say that the company really started to hit the market in about 2015. We got our first set of code compliance in 2016, where code compliant under the IRC and the IBC can build up to 85 feet. And that is what launched it all.
Well, tell me a little bit more. Why bamboo?
Sure. So bamboo, it's an amazing, amazing material. And when you look at the built environment, the built environment is the largest single contributor to global greenhouse gas emissions. And when you have the ability to input a material that allows you to continue to sequester or carbon sink into a durable good, such as bamboo, turning into a panel structuralized form, well, you can make a huge carbon impact. But structurally speaking, our design is very unique because we have essentially a hollow wall, a wall that has been able to eliminate 80% of traditional in-plane materials. So studs, headers, posts, trimmers, kickers, you name it. We are a bamboo wood hybrid solution. But to be able to do that, you need some sort of strong member. And bamboo, timber bamboo, is unbelievably strong, not only in compressive strengths, but in tensile strengths. And so that's why bamboo, because it wins on two fronts. One, it allows you to have a highly insulative envelope, but it also allows us to start to engineer carbon sequestering materials more efficiently and faster into the built environment, which arguably we need.
So tell me more about BamCore and the product that you're offering to builders.
Sure. So today in the market, we have what we call the BamCore Prime Wall System. And what that is it's a dual panel assembly. So you still use traditional wood members for your bottom plates, your top plates, and then any of your window and door blocks. But what it is it's a custom bespoke form of material that's delivered to every single job. So let me step back and explain. We are a custom prefabricated panelized structural wall. A little bit of a mouthful. But what we do is we take a set of plans, any plans, and we effectively BamCoreize it. So we utilize Revit and some other programs. We will go through and we will fully 3D dimensionalize out the building. So we can understand where every single 4 foot wide by either 8, 9, or 10 foot tall individual panels go in place. And then we custom fabricate all of those panels to meet the job's requirements. So every door opening, every window opening, every plug, switch, plate, location is all fabricated here at the factory. What that allows the builder is an ease of installation, right? A lot of the errors are taken out of the job site in building effectively. So when we panelize out a building, we start from a whole set of guidelines where individual seams need to line up. We don't put a seam at the edge of a window, for example. So you don't always have a pure mix of 4 foot panels in a straight run. You have a mix of different sizes, and it's a kit of parts, but it's a very accurate kit of parts that allows you to substantially speed up the time of installation in field.
Great. And so what's that process like when you work with builders? Let's say, they have this plan. So what's that process from meeting with you until kind of setting those up on the job site?
Absolutely. So we are unique in that we are a material supplier, but we are a heavily involved material supplier. So it is always really great to get in on the beginning of the design. There are a couple little nuances architecturally speaking, and let me hit on that real quick because this is really the only architectural nuance that we have. Our base assembly, which is based off of a 2x6 wood plate. So when you have your 2x6 wood plates, you have 2.25 inch thick panels that face nail to that plate. So your outer dimension of your wall starts at 8 inches. Okay, that is different than typical construction. Typical construction, you're building on top of those plates and then you sandwich it. BamCore face nails to all of that material. And so your outer assembly is wider by a little bit. So what's nice is if we can come into the design process early, that's accounted for. If we come into a design process later and the builder is having to make the decision, or the owner, developer, whatever their constraints are, they're having to make the decision of, do I shrink some interior square footage, or do I have the possibility of growing out? I mean, we're not talking mass design changes here. We're talking, maybe 3/4 to an inch of design change. And then additionally, we are an engineered good that goes into an engineered package. So the entire development is engineered with our design values. So we are the structural members that are replacing all of those traditional vertical members in building, whether that's a single family home, whether that's a 5/2 podium structure. Regardless, we are the structural exterior load bearing materials. And so for us to be able to go through and have peer-to-peer conversations with our internal engineer and then the client's engineer, the process really is a smooth process. But we stay involved because once the architect has designed the structure and it's been engineered and we're ready to start to fabricate, we go through a design iteration in-house, making sure that we then are taking the architectural designs and integrating that properly into our system. So there's a back and forth of checks and balances that happen, and we create effectively what is a lookbook or a set of shop drawings. And once everyone's on team, we have approval for all those shops, we start to fabricate. But there's an even bigger process that can go into this. Because we have a 2-dimensional face of a panel, let me show you. So here's a small section of a BamCore panel, okay? Does it look like bamboo? Well, it's because the bamboo's covered. This is MDO, medium density overlay. This is our application for all interior face surfaces. So fire dependent, you can actually either reduce or eliminate gypsum. So you tape and texture straight to this face. There's the bamboo, okay? This is what is exposed in cavity as well as the exterior part of the building. Everything here, this is what allows us to make this very strong structural cavity because of the tensile and compressive strengths of timber bamboo. But because we have a surface that's flat, that gives us the ability to print a set of guidelines or instructions onto it. This is one of our ways to address the labor market constraints that we all are facing. Every single panel has a name, a nomenclature on it. Every single panel has its entire nail and shearing pattern printed straight onto it that's color coded. So you have color coded top, bottom plates that are the same. You have color coded nails for your seams and all your blocking. And then we can take it even further. If the design team wants us to integrate electrical layout, plumbing layout, if there's HVAC inside the wall, we can, through Revit and through BIM, Building Information Modeling, we can then print all of those guidelines on the panels. So instead of having a crew look at a plan set on site, they're now just following a kit. They're following paint by numbers where the electrical is going. Literally, the electrical lines are printed onto it. where the standoff clip for the electrical needs to go, where the slope of the plumbing line needs to run. So we have the ability to do all that as well. And that has become, almost a namesake of ours. Internally, we call it MEPI mapping. It's a little bit of a mouthful again. Mechanical, electrical, plumbing, insulation mapping. But it gives us the ability to, again, address the constraints that we're faced with as an industry in regard to labor and skilled labor. We still want to keep the nail gun in the framer's hands. All right. This is an on-site build, but with factory efficiencies. So we take the time upfront in the design to make sure that we can deliver those factory efficiencies to the job site. But what we've seen is about a 50% increase in framing alone. So if we use a basic metric of a 2,500 square foot box, okay, we do much larger than that. We do hundreds of thousands of square feet, but let's just take a box, okay? The rule of thumb would be that with a good framing crew, that first day you are completely stick built. Day 2, you shear your building and then you cut out for your windows and doors, et cetera, make sure everything's good to go. And then on day 3, you're flying your trusses and you're applying your subroof. With BamCore, because we are a load and shear material, you're not adding OSB onto this. This already is shear. So by the time you get those 2 panels in place, the metric is about 3 guys, 2,500 square feet, 5 hours. So in day 1, the entire structure is framed. In day 2, you're applying your trusses. So that's a 50% savings right there in that metric. And largely that's what's being utilized with developers that are actually utilizing the material right now in Utah and California, Washington, DC, and other states.
So from what I'm understanding, obviously you're located in California. And so you have one factory there currently where you're manufacturing these panels, correct?
Actually, it's a funny story, but we are bi-coastal. And we're bi-coastal by means of opportunity. We had an opportunity to purchase a retired Georgia Pacific glue lam LVL production facility in Ocala, Florida, of all places. Okay, we're headquartered in wine country, Northern California, but then all the way across the seaboard in Ocala, we have a plant. As of right now, all of the sheet goods, so the manufacturing of the bamboo and the wood panel happens in Ocala, and then we either rail or truck panel inventory to Windsor, California. And then the fabrication, the bespoke customization one-off happens in Windsor. Now I've used the words one-off and bespoke, but the nice thing is this is easily repeatable on mass jobs. What the one-off and the bespoke points to is that we make sure everything is fabricated exactly the way it needs to be to plan. And so it is custom to that individual plan, even if that plan is being replicated 50 times over. We have all the files for it. So yeah, we're bi-coastal. And a lot of people then go to, well, what does that do to your carbon footprint? I mean, it's interesting. We're very concerned on carbon. We've have 2 LCAs to date. We are going to be finalizing a EPD, likely a UL EPD, hopefully within the next 6 to 12 months. By having our raw material come into Ocala through the Gulf actually was a better picture as far as the shipping constraint than having all of the bamboo effectively ported into the port of Oakland, which is what we did for a very long time. And with the established supply chains, the transportation logistics that are already there, it really was a moot point as far as our emissions are concerned. But that itself is a whole other topic. You know, I mean, it's very interesting, but you know, we didn't want to take nature's strongest botanical fiber, nature's strongest botanical fiber, nature's fastest regenerative botanical fiber, and adulter it. We really wanted to be able to harness what nature had laid out in front of us. We just got lucky and were able to do it in such a structural manner that it can actually make an impact two ways.
One of my questions connected to that as well, you being in California, are there limitations for delivering these systems across the country?
Yeah. So no, there's not. The one limitation that would be there would be if we did not have code compliance, and if we were having to go alternative means, materials requirement for every jurisdiction that we supplied material for. That could elongate the process from contract to delivery. But because we are code compliant under the IRC and the IBC, you know, we have a stepping stone already, and we've showed that we are equivalent or better. In most instances, we're better in everything to a like design building with traditional materials. But what it allows us to do is there's no barrier. And we've built as far west as Maui, we've built as far east as DC, and we have demand not only throughout the United States, but Canada and outside of the United States, Latin America, Europe. You know, we have people that call us almost on a weekly basis, either from Sweden, Denmark, England, Spain, and then India, that really want to be able to utilize the material. We're just not there yet. Capacity, it's not possible for us. You know, one step at a time is what we're doing.
I would love some more details about things builders should know about the strength and the features of bamboo and how that compares to the traditional lumber they use today.
Let me hit on bamboo real quick. So bamboo is a rhizome-based system. It's a grass, okay? When it comes out of the ground, it comes out a culm. It's called a culm. It shoots. And it comes out of the ground at its diameter. So whatever it's going to shoot vertical, it is already its diameter. It'll hit its mature height within 6 to 9 months. And that's anywhere between 50 to 120 feet. And that's species and location dependent. That material, depending on the stand at which it grows out of, by year 4, actually arguably 2.5 years to year 4, it's ripe for harvest. So again, going back to the carbon, you know, if you look at a tree's carbon life cycle does this kind of movement. All right, it comes out of the ground as sapling, and then you get to a good harvest rate, you're 25 to 75 years. Bamboo does this, and it never dies off. There's no clear cutting of bamboo. Again, imagine you have a lawn, right? You mow your lawn, well, a week later, 2 weeks later, you got to mow it again. It's the same base system. It's a rhizomal system. Strength-wise, this is where we really start to differentiate ourselves. Our product has a very high vertical capacity. For a 10-foot wall, 5,805 pounds per foot. Okay, if you look at that, and 8,000 up to 8,095 pounds per foot, depending on blocking conditions. For comparison, a 2x6 number 2 Doug fir framed at 16 inches on center at that same 10 feet has a vertical wall capacity of 5,200 pounds per foot. That's also equivalent to about a 1.8 E LSL member at 16 inches on center framed to about 8,600. So at first you have our base assembly, 5,800 compared to 5,200 of Doug fir. And then with additional blocking, just a couple transverse blocks added, we are now exceeding equivalency of LSL members as vertical members. Here's another really neat thing. You can take our panels when they're in vertical orientation, which they're observing the compressive strength. If you oriented that panel horizontally, you've now turned it into a tension member. So you can almost always, even 5 stories, almost always replace a 6x select structural Douglas fir header with a BamCore in plane header. But here's the thing, that's hollow. You still maintain the cavity. It's just our panel's done this. So you have a BamCore panel, another one next to it, and you have a in-plane header that you can now insulate. So you don't have a solid cross-channel material.
And then, another obviously huge issue right now, supply chain disruptions, cost. And I'm really curious to know about how that's affecting BamCore and maybe how that differs from lumber as well.
Sure. So supply chain logistics in a good year is a nightmare, regardless. Bamboo does not follow a supply chain or even have an infrastructure like wood does, okay? We are not susceptible purchasing bamboo to market volatilities that wood is. The only volatilities that we have to look at with our that's grown overseas is one, what the political environments are looking like. And we have to, so we invest in our suppliers, not only to make sure that one, they can harvest in a way that makes sense for them. They have the resources to do so. We're very stewardly in that way. We like to come in, establish relations. We don't come in and say, hey, we want you to do this, you're gonna get paid this, and walk out of there. We are very much actively engaged in these communities and these locations. It is a nice partnership. I say partnership because we have a partnership with every single one of our suppliers in all of their offshoots. As far as logistics are concerned, I want to make one mention of something. There's 1 billion hectares of wood in the world. All right, 1 billion. All of that is not usable, okay, but that is the total amount of wood in the world. There's only 40 million hectares of timber bamboo, okay? A hectare is 2.41 acres. So that's 1%. There's 1% of bamboo that's in the world planted compared to wood. There was no global supply chain of timber bamboo established before BamCore. Arguably, it's our single largest intellectual property asset that we have, because we figured out where it all grows, where it is, and then engaged with the people that have access to it. Our scale, our approach to scale for market rollout, it doesn't take much bamboo to make a big impact in not only supply of jobs, but in carbon as well. So to give you an idea, our plant that we have in Ocala, Florida, its max capacity is about 1 million panel equivalents. Easy metric is a single family house is about 200 to 220 panels. Let's just call it 5,000 house equivalents is what one plant can do. So we only need 25,000 acres will feed one plant. And to give you an idea, we have access to multiples of that. It's just a matter of financing out the plant, which we're actively doing, or we're actively engaged in a Series A financial round to help us scale. But 25,000 acres will feed one plant permanently. And that's 1 million panel equivalents. Today, we are limited capacity, which is a pain point because there's so much demand, but it's this teeter-totter of getting an influx of capital to allow us to scale, to get to the next step, to be even more impactful. And so that's what we're doing right now. So then we can continue to address this. And by the way, if one plant is at full capacity, it's not just one plant that's operating, it's multiples. And that path is laid out in front of us, and it's just a matter of making it happen. It's a matter of financing it out and then moving forward. But if you look at the market boom today with lumber, BamCore, we were never trying to be a material for material swap. Okay, we always carried a 10 to 20% premium. If you look at it, it's an engineered good. There's multiple inputs for a single output. So arguably your cost is going to be more no matter what. So we either carried a 10 upwards of a 20% premium, but there are so many impacts throughout the entire build and budgeting process, from how much concrete you need in your foundation to your finished siding, that there's impacts that we create. And so that 10 to 20% is easily washed to bring us back to par or under budget with almost every single bid that we have come across. With today's lumber boom, though, it has really shone a light on the opportunity. And that's because we are not only showing that we are easily material now making a swap, but that people can substantially save some big dollars. And that has been evidenced as some of the bids that we have done recently with some large national affordable multifamily developers. We've seen a material savings as much as at least $300,000 and more. And then they have hundreds of thousands of dollars of potential savings in other places, again, because you're utilizing this material. When you have the dual panels, you have a highly thermally performing envelope. That right there allows you to then reanalyze how everything else is. You can put different windows in. Your HVAC system is more economical. It can be higher performing because you maybe have 2 air changes an hour instead of 4.5. It truly is a systemic change. It's an approach that allows you to look at everything and model out in such a performance way, in a design energy way, that you can obtain savings throughout the entire development. So, I mean, we're very, very much honored to be a winner of the 2021 Ivory Prize. And there's quite a few other things that we're doing. We recently were approved to be a newly added assembly into California Title 24, because we were able to prove thermally we're unlike any other material. And so you have a higher starting point to be able to design out the structure and look for it. In California, they operate in overall U factor. And in 13 of the 16 climate zones, yes, California has 16 climate zones because we need them. We exceed the minimum threshold in all of them. And that's with no continuous insulation applied to the outside of the building. So you have unlimited design needs. I appreciate you guys reaching out to us. I mean, it's a pleasure. It's an honor to be on this with you. This has been a treat. The time is now to look. By no means are we just pro bamboo. I mean, we are pro wood. We are pro bamboo. We are a bamboo wood hybrid material. It's the cross section of integrating those two materials that we have a chance to not only make an impact in the building, but then also decrease our impact in our global warming effects.